Al-Handasah YouTube channel. This is third part in cracks series. In this lecture I am going to discuss the second type of cracks. Let's start. Plastic shrinkage cracks. Plastic shrinkage cracks form due to rapid early drying and a low rate of bleeding while the concrete is still plastic, means not set. Plastic shrinkage occurs mainly in concrete elements with a high surface to volume rate, such as slabs in pavements. Air and concrete temperature, wind speed, the warming and drying action, and relatively humidity all play an important role in the rate of moisture evaporation from setting concrete. Rapid drying of the surface of the concrete causes it to shrink and crack, similar to the cracking that occurs in clay soil as it dries. Plastic shrinkage cracks may form in a random pattern, or they can appear in almost parallel pattern. The cracks are often almost straight, ranging in length from 25 mm to 2 m, but are usually 300 to 600 mm long. They can range from 1 to 3 mm wide at the surface and are superficial. You can see plastic shrinkage in this picture. These cracks are plastic shrinkage cracks. Impact of these cracks. The cracks usually do not extend to the perimeter of a slab, and it rarely impairs the strength of a concrete element. They normally only impact on the aesthetic appearance of the concrete. However, it is important to keep a close eye on these cracks, as they can potentially form a weakness in the concrete. With subsequent drying, shrinkage, thermal movement, and/or loading, the cracks can be deepened, widened, or extended, which may eventually cause a crack to penetrate right through the concrete element. This crack may lead to water ingress problems, since it can start acting as a passageway for moisture and dissolved salts. This issue can lead to rusting, reinforcement, steel, concrete deterioration, and spalling if left untreated. Fixing of these cracks. In pre-hardened concrete, while the concrete is still plastic, the surface can be worked with surface vibrators to close the cracks while ensuring that the concrete reliquefies so that the cracks close fully. In hardened concrete, where they are of concern for water tightness and/or protection of the reinforcement steel, or the cracks are 2 mm or wider, the cracks should be filled with a suitable property filler. The cracks may be V-cut with concrete chaser and filled with suitable material. Minimizing of these cracks. Dampen the substrate and formwork and remove an excessive water prior to placing the concrete. Second, use of sufficient quantity of synthetic or steel fibers in concrete to help offset the effect of plastic shrinkage. Third, in hot weather, lower the temperature of the fresh concrete by using chilled mixing water or replacing some of this water with crushed ice. Fourth, installing wind breaks. Fifth, immediately after spreading the concrete, apply aliphatic alcohol over the surface. This water-based finishing compound effectively controls the evaporation of bleed water.